Let's check the assertion that the equation y prime plus y equals 0 has solution y equals e to the negative t. We need to evaluate y prime. That's e to the negative t prime. The chain rule, the derivative of negative t is negative 1, so we get e to the negative t. So the equation becomes negative e to the negative t plus e to the negative t equals 0. This is true. Let's try this one. Now y is going to be e to the negative t squared over 2, and we have y prime plus ty equals 0. So let's see, y prime is chain rule, derivative of negative t squared over 2 is t, negative t. And then that's times our basic function, e to the negative t squared over 2. So when we substitute, we get negative t, e to the negative t squared over 2, plus t times the y function, which is e to the negative t squared over 2, equals 0. And this is true. Let's try this one. Y equals e to the cosine t, so that y prime equals e to the cosine t prime, which is cosine of t prime times e to the cosine of t, which is negative sine of t e to the cosine of t. We plug that into the equation and we find that it works out. Negative sine of t e to the cosine of t plus sine of t e to the cosine of t equals 0. By now we might think we're starting to see a pattern if we think about what's going on. Our y prime function matches up with our y function in such a way that the term we get from applying the chain rule is equal and opposite to the coefficient of our y function, causing in each case the two to be equal and opposite and making the equation true. Now, because of the way the exponential function differentiates, it turns out that we can do this pretty much in general. Let's try thinking through the solution of y prime plus t squared y. What's the solution? Well, it's e to the something whose derivative, that is the derivative of the whole e to the something, is negative t squared times e to the something. What is the something? Well, to get a negative t squared in the derivative, we have to have an antiderivative of negative t squared up here. What's an antiderivative of negative t squared? Well, that's t cubed over 3. E to the negative t cubed over 3 has derivative negative t squared e to the negative t cubed over 3. And we can plug this back in here, take its derivative and check and make sure that it really works as advertised.